Alrighty, let's see what we got here. It's going to be a medium that I saw previously. Count mentions per user. You're given integer number of users representing the total number of users in an array of events size n times 3. Okay. Each event at I can be either one of the following two types. It's a message event or an offline event. The message event has 3 items: a message string, a timestamp, and a mentions. This event indicates that the set of users mentioned in a message was mentioned in a message at timestamp I. The mention string contains one of the following tokens. It's going to contain an ID number, ID bracket number, where number is an integer in the range of 0 to number of users minus 1. There can be multiple IDs separated by a single white space and can contain duplicates. This can mention even the offline users, all, or here mentions all online users. Offline, this indicates the user ID has become offline at timestamp for 60 seconds, or 60 time units. The user will automatically be online again at timestamp plus 60. Return an array mentions where mentions I represents the number of mentions the user with ID I has across message events. All users are initially offline or initially online. If a user goes offline and comes back online, their status is processed before handling any message. Okay. Note that a user can be mentioned multiple times in a single message event, and each mention should be counted separately. Number of users 2 events. Message 10. 10 is the timestamp. ID 1, ID 0. So a message going at timestamp 10 to both user 0 and 1. Offline at time 11, 0 goes offline. Message at timestamp 71, which is 60 more than this thing, which is when 0 comes online. Here is, I guess, when it's online. So this could be both users. So return the array that is the count of the number of times each person was mentioned. I see. So they were both mentioned for this message and this message. Number of users 2 events. Message 10, both users. Offline 11, user 0. Message 12, all. This is very much similar to the last one, but just actually, what was going on here? Offline at 11, 0. Message at 12, all. Actually, shouldn't this be 2, 1? Oh, all includes offline users. Okay. That was actually a useful example. So here's online, all is all. Okay. Offline, user 0. Message everyone here, so it should be only the user 1 that gets it. Okay, I kind of vaguely remember having done something this. This is quite convoluted, but let me think, how would I approach this? it wouldn't make sense for me to try to actually there's a pretty small number of events here. I was thinking it wouldn't be usable to go through every message and go through every user that's online, but maybe it is keeping track of everyone that's online at the moment. Keeping track of everyone that's online. I think I can't. Can I sort? No, can't really sort here because the maybe I can sort by timestamp. By timestamp. Do sort by timestamp. Can I, if I sort by timestamp, can I inline process everything? Maybe. Maybe. I mean, I think it's slightly better to create my own tuple. It's better to create my own tuple rather than try to do some sort of sorting and then inline processing of all the messages or all the events. Like I think I probably need to keep track of. What do I need to keep track of? Is it a heap? I need it. Might be a heap. Probably a deck, to be honest, because if I sort it already, if I sort it, then I just need to, when someone goes offline, I need a deleted queue to track when they get online again. When I process an event, I first process the queue of people that might go back online. Yeah. A set of users online. Users are only up to 100. I mean, it might be better to the number of events. Geez, events. Integer of events I minus 1, I into I part 1. Okay, the time itself is between 1 and 10 to the 5th. It's fine. Alright, I think I need to have a set of people online. And I guess it should be just every user. This would be the number of users. I think it's just range is the operation I want to use rather than creating a list. Okay, so that created the set. Okay, I think I want a double-ended queue, so duck for just an empty duck maybe. Needs to have tuples of kind of timestamp when they come up online and user. I wonder. Offline is not a list. Offline is just a single person. If it was an offline list, I might need to keep track of the list of things rather than just user, but this should be fine. Tuples of user when they go back online. Or when tuples or when user comes back online. Guess I probably need a answer array of size number of users. And then I just parse it, right? No, I need to sort it first. So I guess I'm going to try to parse it in line rather than create some other data object. Events sort key is lambda x. So for each event here, I'll say lambda e for event. I want to sort by the event timestamp. So that'd be e index 1. I wonder if you can have people go on offline and message at the simultaneously. Probably, right? The user goes offline and comes back online, their status has changed before processing the handling of any message. So I need to sort based on timestamp first, and then I need to prioritize offline over online, offline over message. So I need to make sure that the offline status changed before the message comes out to like people that are currently online. So that'd be reverse sorting. M is alphabetically before O, so I think I need to reverse sort the second part. I don't know if this works though. A negative of E 0. I think I can't make a negative of the. Let me go ahead and see what happens here. I mean, yeah, I don't think I can make a negative of a string. Yeah. So how do I do a reverse sort? Actually, I don't even know if I can do a. Can't even do yeah, this just didn't work. Sorting strings wouldn't work because like 100 would come before 71. Because the 1 is alphabetically before the 7. So yeah, I'd need to make some sort of event tuple and then sort those event tuples. Eek. How to do this? So I'll need event, let's say event tuples. So for every event in events, so how to do this? So the tuple should be, tuple is going to be something like timestamp first, then the type, the message type, and I'll say this will be equal to 0 for offline, 1 for message, and then I guess the message could be here, or it could be, the message could have a list, all or here. Okay. How to store that list, I guess. I guess I need to have some sort of ID indicator. I wonder if I can store a list in a tuple. I don't think I can, because tuples need to be hashable. I think I probably have a I'll have an ID list. It'll be like a default dictionary, and this will be a list. This will be message ID is the key, or event ID, event index. The event index is the same thing as event ID, I think. And then the value is the list of users for that, for the list of users messaged, for those that need that information tracked. Okay. So for every event, I need to parse it here. So it'll be 3 strings. It'll be the type string, the time string, and the user string is this event. I think this might work. I don't know if actually this might work. Maybe I can do this. I don't know if it automatically unpacks like this. I don't know if this automatically unpacks. That definitely. Okay, I guess it did unpack it like I was hoping, I guess. Okay. But I still need the ID. Or I still need the index, actually. Okay, so yeah. I'm going to have this. So n is the length of events. For every, let's say, e index, ein index in range of n. We'll say that those values are unpacked from events at index. Double check that this works. Okay. So now I need to convert the time string to a time value. So time is equal to, I think I just do time integer time string, and then type, oh shit, say type val is I don't need to use that. Message is going to equal 0, 0. If type string equals message, no, offline, else is going to equal 1. And let's go ahead and just print out those two, see if that's correct. Okay, 10, 1, 11, 0, 71, 1. Okay. And then parse the thing. So if it's here or if it's all, I guess I'll just do an else if statement here. If user string equals user string. Wonder if I should do one of those switch statements here. No, it's probably fine. I just do it. Oops. User string equals all. I guess that I could just make that mean I guess I can make that a negative number because I want the tuple to reference a positive number if it needs to reference the ID list. So let's say ID, message ID or user ID equals -2, else if user string equals online, oh here, user ID equals -1, else I need to parse and store the list into the ID list. So user list is going to be I need to parse this ID what was the thing? It was like split rusty with my Python string manipulation. Alright, separator optional delimiter. If not specified, default is white space. When a specific separator is provided, consecutive occurrence of that separator results in empty string in the output list. Default is white space. When a specific separator is provided, consecutive occurrences so that separator's results. Limit number of splits. Split by specific character. Specify the delimiter as comma. Well, if you want to have multiple and you have a separator list of separators rather than just using single white space. I want to kind of have split space on white space plus ID, string ID. Commas, space, pound. I guess I can split first using spaces and then split and then remove the ID from that. Yeah, I guess that works. So it'd be split. It'd be split using spaces, then parse it from the second index onwards of the string. So I think it'd be something like user string dot split. So that returns me a list, right? That returns me a list of individual IDs. And then I think it should be something like list comprehension of the integer of s, say user from 0, 1, 2 onwards. So that's going to remove the ID portion of the string for every user in this construction. Go ahead and print out the user list. And I think it should be something like ID list at whatever index this is equal to this user list. Wow. Yeah, I think this is fine. Literal for int base 10. Okay. Guess I went too deep here. Let's say string split is equal to user string dot split. Print out the string split. And then I'll just break here. Just comment this out. So ID 0, ID 1, ID. Interesting. Okay. That's not going to work, is it? Forgot that could occur. That this could be message with the offline type. So, oh boy. So, yeah, let me think. So I need to do this only if this is a message that is of type not offline. So if message is, I guess I should just wrap this in an if statement here. If type string equals offline, then message equals 0, and then parse the integer. User ID is equal to integer of the user string, else message is going to equal 1, and then all this occurs. Okay, so maybe this was okay, but it's just making an error from that assumption, correct assumption. Misspelling, excellent, excellent, type string. Okay, did I not print it out? I did. Okay, user list is 1, 0. Okay, that's 1, 0 right there. 1, 0. Okay, sure. Okay. Alright, and then I just need to add this tuple to the event tuples. So this is going to be, the user ID here should be the index. Yeah, I think that's right. I guess I could also just say the user list is just going to be ID list if this index is stored directly. This is really complicated, single statement, but whatever. Convert user string to list of integers, list of user integer IDs, and store in dictionary. Okay. And then last but not least, event tuples is going to append the tuple for this event, which is going to be the time, the message, and the user ID. And then go ahead and sort the event tuples. And I'll print out that. Okay, so the first in order. I wonder if these events are not in order, right? Can't just assume. Yeah, there's no mention that these events are in order. Is guaranteed that user ID reference offline event is online at the time. User ID referenced in the offline event is online. Yeah, sure. So timestamp is 10, 11, and 71. Message is 1, offline is 0, message is 1. ID here is 0. So within the list of list of it, it should map to 0, 1. This is just an offline message, so it just says a single user ID. -1 is to indicate we're here. -2 is for all. Okay. I think I can now go ahead and parse the events in order. So parse the events in order. So I think I need a time indicator. No, I guess I don't need a time indicator. Because the time is whatever the current event parsing. So I can do something like for every index in the range of n, which is the number of events. So first I think I need to bring back online anything that's offline at this time. Yeah, so current time is going to be whatever event time it is. So event tuples at this index. Actually, I should probably just unpack. So it'd be time, message, and user ID is going to be event tuples for this index. And then bring back online everything that is offline. So why yeah, I guess while there is something in the deck and at the front of the deck in the front of the deck has a time that is less than equal to this current time, then whoever is offline comes back online. So it should be something like don't care about the time information, just the off ID is going to be, the offline user ID is going to be deck.popleft. I think that's the thing. Is it lowercase python double-ended q popleft? Popleft underscore. Sometimes I confuse myself with the capitalization. I guess everything in Python's kind of lowercase. And now I say, I have a set of things that are online, so I need to add that to the set thing online. Actually, maybe this should be just, should be a set. Yeah, it's a set. Yeah. Like I was thinking maybe I can use an array, but it's not going to be easy to iterate over the online folks with an array. So that should process everything that's offline that needs to go back online between some previous time and the current time. And now I can process the event. Okay, so this is bring back online all offline users whose end time is before current time is less than or equal to current time. Okay. And then now it's just about parsing the single event, the event tuple here. So first, based on message, if message is equal to 0, which means it turns something offline, then the user ID is just that person's ID. So I think online dot remove this user ID. And then I need to add to the deck this future tuple for when they come back online. Guess this probably is more pertinent right here. Online is I think this could be moved down here too. event tuples, ID list, and events. Yeah. Alright, so the dev needs to append the tuple for the timestamp, which should be time plus 60 or time plus 61. So if time currently is 0, actually, what was that one example? So time is 10, it's offline at 11, it's back online at 71, so time is 11. So if I do plus 60, then it'd be 71. 71 would work here, less than equal to current time 71. So yeah, I think it should be times plus 60, and then um, and then what happens? The user ID. I think that's it. That type message. And then otherwise it's a direct message to certain users where I have to increase dimensions. So let's do if user ID is equal to, so this is a message to certain users based on user ID. So if this is -2, then it's everyone. That's everyone. If it's everyone, I wonder if I should. Maybe I should ignore that actually. Maybe I should ignore that because I don't really want to iterate over every single person and increment them. That's just kind of waste. So I think I'll just have a all message count. This is message to all users. This is the number of messages to all users. And I actually might just skip creating something for it, to be honest. So if the user string is all, increment it and then continue with the for loop. So all count increments. Continue. Because then I can just say that when I create my default mention counts, this is going to be based on the all count is the flat baseline rather than 0. Okay. Okay, so I think that's fine. So I don't have to worry about all messages. So now it's just based on user ID. -1 means it's for online users, so I need to iterate over every online user. On user is going to be in the online set. The answer for that on user increments by 1. Number of mentions for that person. I think that's it. Else I need to go through the list, and the list is going to be, I guess I could have stored the string itself and parsed here, right? I could have stored the string itself. I guess I don't need to do this. I wonder if I can compare strings to integer. Let's go ahead. print -1 equals. I wonder if this is going to be an error. Alright, yeah, close up this. Okay, I guess, yeah, I could store a tuple with it here. Then I wouldn't have to store it within the default dictionary. I mean, it is a string anyways, so it's just a reference to that memory. Yeah, okay, let me think. How would I do this here? User ID is a string. Yeah, I guess I could just store the user string as the user string. And then I wouldn't even convert per se. Okay, so this code is interesting. Yeah, this code is just a little too complicated or unnecessarily complicated. So time message user ID, or user ID is just user string. Yeah, so maybe that's probably. Okay. I guess I don't need sort base in it anyways. So in that case, then I can remove that there. I can even remove this, right? Because it's just skipping it based on. Maybe I should just comment this out. Wonder. I guess all. No, I guess this is fine. This is fine. Message. I did need to convert the timestamp. I guess I could have done a key of the time. Interesting. Could have done a key. Yeah, thinking too much here. Okay, so the ID is now just a string. So this is no longer user ID, it's user string. So here I need to append the integer of this. Yeah, this integer is user string. I think I need another closing parentheses, yeah. Message to certain users based on user string. Okay, so if the user string is here, then everyone that's online in the online set increments, and then else I need to parse. So I think I just need to convert to ID list. I think this is still fine. It's going to be ID list of that list comprehension. So I think this is just the ID list is going to be that. And for every user ID and the ID list on answer at that user ID increments. Okay, actually that, yeah. It's always surprising when you finish the last actual statement. User ID is not associated with the value. Allow this to be user string. User string for every user string. User ID. Index at a range. Oh, I see. Really? Oh, I see. All right. Because the certain events don't actually create event tuple based on the skipping all. So I think it should be n minus. I could do just the length of event tuples, or I can just do n minus the number of all count, number times all is used as an event. I think that's probably fine. Okay. What errors? User remove. So this is a string now. I guess I use user ID is the integer of this user string. I'm not sure why I call it user though. User ID. I guess they did mention this online users. Okay. Guess that's fine. Let's see how this runs. And then hopefully it works, and then I can clean up. Sweet beans. Okay. So I think I need to just delete that. All that can go. Okay. So your events, you have a tuple. So I was thinking in there, in the midst of my jumbled coding thoughts, that maybe I could have skipped over creating this event tuples list again. But you're gonna have to parse the integer timestamp. You have to change that timestamp from a string to integer during the parsing of the sort. And then you'd have to do it again during the actual parsing of or iterating over the sorted events if you were to do it in place. So yeah, I think it's probably a lot, well, certainly a lot easier and maybe even more efficient to have an event tuples array, the sort event, and then sort that array. So tuples timestamp, yeah, 0, 1. I don't need this ID list anymore. All count of all messages, count of messages all users. Array index, get the strings, parse the time, message is offline, then message value is going to be 0, otherwise it's 1. If it's 1 and the I guess maybe I can reverse this. Slightly better if I reverse it. If the user string for a non-offline or normal message is all, then all count increments skip it. Otherwise, the message can be 1. Message value is going to be 1. Event tuple, time, message, and user string. Sort. Online users have a deck of tuples for when people come back online. Is there a better way of doing this? Kind of do need to keep track of it. Yeah, I think this is fine. Answer array starting with the number of all counts instead of 0. Oh, it's a misspelling of count. Cout. Cout. Is that C++ out? Yeah. Okay. Get the current event at this index. Bring back offline users. Is there a way for me to prevent having to check the front of the array? Can't. Yeah, I have to do that. I can't always place a placeholder that sticks. Yeah. So the ID is the second item that tuple in the deck. Bring that thing online. If the message is U0, then this is bringing someone offline. So user ID, parse the string, move them from the online set. Add a tuple for when they come back online. If the user string is here, go through all the online users set in the online user set. Increment their mentions. I think this is fine to parse the string. Split, convert every token to integer. Yeah, okay. Summary. This is well, a couple of key ideas. One is one need to sort based on timestamp, increasing, but reversed, but decreasing on based on timestamp increasing, and kind of offline before offline is before online, or offline is before message. Use a separate array of tuples that were kind of the time, the integer time, and integer message type. Again, 0 for offline, 1 for message. And then a user string. Secondly, ignore or keep track of messages to all users as a count, rather than rather than creating an event tuple for it, since that is baseline mention count for all users instead of 0. So if there's like 10 messages to all users, then instead of just at some point incrementing every single user by 1 10 times, just start that count with 10. And then, oh yeah, last but not least, keep track of when users come back online using a double-ended queue, tuples time and user ID. Check that queue at the start of parsing before parsing any event, or I guess not parsing, processing an event. Bring back online users whose timestamps is before event time. The rest of it is mainly bits of string processing, parsing. For example, the converting user string to list of integer IDs if necessary. Like this little bit of code, which can be done in a for loop or with this comprehension. Okay. Time complexity can be O of n to iterate over every event and convert to tuple, and to iterate over every tuple, which is roughly the number of events except for the all mentions event. Doing constant work. But there is sorting involved. So actually, it's O of n log n. In practice, I would expect that parsing is going to take longer, especially given some of the conversion of integer to string or string to integers. That the sorting is going to be pretty fast, but in theory, it should be longer. It could be longer than the iteration. Space is going to be O of n to create the tuples, the event tuple list, or to store the event tuple list, and have the deck double-ended queue, which which in theory could be the size of all the events if everything happened at time 0, I guess, something like that. Which worst case might be n. Okay, cool beans.